Oh, okay. Thank you so much.
Yeah, and if anybody has any issues with that, feel free to pop off video, but mainly it'll just be the screen that Cici's sharing here, and we'll be making the recording available on our YouTube page afterwards.
Yeah. Okay. So we will start by creating the R Markdown document. I hope this size is good enough for you guys. And then we'll get started. So first we will introduce the if and else loop. So the syntax for the if and else is like this. If the condition is true, for example, we set a variable called x, and we set it to a number 5. We say if x is greater than 2, then do the following functions, like for example, print a piece of string that says x is larger than 2. And if this is if the condition inside if is false, then we can operate the R will just automatically operate the following. We can say that x is less than 2. And then we can run. This is a typical if function. Basically, if we can also just delete this part and just run this part. As long as the condition inside this bracket is true, then this command will like run. And then okay, so we also want to try to add more like conditions, so we can just say if else, and something like this, and then if else, and then give it a condition. For example, if else x is greater than 2 and x is less than 7, then we print this message that says x is between 2 and 7. So you can add as much if and else statement in between if and else statement. But whenever you want to add like you must start with the if statement first. Yeah. And we can always change this number, like for example, like 7, and then see how it goes. There's something wrong.
Cici, I think you need to flip on line 15, like else, and then if, because you right now you says
And 7.
else.
Line 7.
6 is better.
Sorry, where?
And the first 12 row, and maybe it's 6. You have the answer. Because it's
else
less.
sorry. It's else if. Okay, sorry about that. Now it's running, yeah. Okay. So that's the basic if syntax. And now we can talk about the for loop. For a for loop, we just need Okay, so there's another function called if else. Like we can just do if else, and then we say the condition x is larger than 2, and then comma, as long as this condition is true, we print this message. It's x is larger than 2, and as long as this condition is false, this message will be printed. So x is less than 2. And then you can see that as long as this condition is true, then this will be printed. And as long as this condition is false, this will be printed. So this is the if-else function. And now we can talk about the for loop.
Well, Cici, can you maybe go a little into why we would use in what cases maybe we would want to use the function if else versus just typing out like the long-handed way that you've shown at first, the if else statement, writing it that way?
Okay, so we can, for example, we can load the library gapminder, and then library tidy birds, and then library gg bot. Yeah. And then if we want to like for example, gapminder data set, and we want to group by country, and then we want to subset, like for example, add a new variable, for example, mutate, add a new variable, for example, if the year is the life expectancy is greater than, for example, 50 years old. Life expectancy greater than 50 years old, and then we equal, and then we can just say if else the life expectancy variable for each observation is greater than 50 years old. If this condition is true, then we can give this new variable and say it's true or false if it's not greater than 50 years old. Or we can also do something like this. We can give this variable, say, like print to this variable. If this condition is true, we say this country, or just say the life expectancy is greater than 50 years old, probably. And then if this condition is false, we can just print to this new variable and say that life expectancy is less than 50. And then we can try to operate this, and we can see that this is the original data set, and we can see the newly added variable. It says life expectancy for this country at this year, this country at this year is less than 50 years old. And then this country at this year is greater than 50 years old. In this case, it would be like much more efficient to use this kind of if-else function rather than doing this kind of thing, because you can't really, I think, you can't really like copy paste this part into this part. Yeah, I think so.
The mutate function will only take
Yeah,
other functions. Like you could do that, but you would have to write a function, which you'll talk about later if you did need to do that. But if it's for simple things like this, it's pretty easy to just use the if else function to accomplish that.
That's right. And now we will talk about the for loop. Basically, the basic syntax for the for loop is just for, and then you create some variable, and then you say it's for in a piece of vector, and for in 1 to 5, and then as long as I is from like this, then this the inside piece will be executed. And then so for I in 1 to 5, we can say print I. And then for this piece, when you run it, you can see I will start by taking the value 1. And then when it takes the value 1, and then it executes whatever code is inside. So it prints the value of I at when I is 1, and then it prints 1. And then after it's printing 1, I will automatically increase by 1 unit, like to 2, I equals to 2. And then it will print 2. And then I will increase another one to I equals to 3 until I equals to 5. So the last one is I equals to 5. So this kind of, this is a basic syntax for this. You can change whatever the variable you want. It's just like a private variable inside this loop for loop function. So you can say it's like a temporary variable, for example, like this, and then you can just change a temp. It works the same. Yeah. And you can also do something like this. You can just say, for example, a just a vector, and you say it's 1 to 5, and then you copy paste the vector to here. It works the same. Okay. This, okay, it works the same, yeah. And you can always change what's inside.
You see, getting an error where the object I isn't found. And if you scroll up, I think a little earlier when you were showing the for loop.
For loop.
Scroll
Okay.
up a little bit when you first defined. You scroll back up a couple lines, a little farther, a little farther. Oh, did you change it? Oh, sorry.
Yeah.
Oh, okay. I think
you mean
because I was just replying to someone's question, so I don't think I caught that. I don't think that chunk of code you were meaning for people to run because you didn't define I yet, but
Oh yeah. Actually,
that was just an example.
do you mean this I, like here?
Yeah, he's mentioning that.
I think like because I is basically inside this it's like private variable. It's not a global variable. Basically for private variable it's it only exists in the inside this function, inside this loop. So when you define I here, and then but you cannot you define I inside this function, but when you run I outside this function, it will only give you the last digit. It's not a global variable. Yeah, I hope that answers your question.
Yeah, I think that answered Juliana's question. Thanks.
Okay. So we will continue with the for loop. Okay. So we can do something like this. So we can run a for loop inside another for loop. For example, I in 1 to 5. And then we say like for j, another variable in 1 to 10. For I in 1 to 5 and for j in 1 to 10, and print I and print j. So we can try this and see how it is working. So okay, I see. So I have to cat. So cat basically means it's also like it's like basically combining this whatever I is taking the value and whatever j is taking the value, is printing a string, like a message. Like you can see okay. So for I, so first step is I is taking 1, and then it goes to the next for loop, and j is taking 1, and it's printing 1 1, like with this function cat, and then j will automatically increase 1 more, and then it's printing 1 2. Why it's printing okay, I see. How about we do this? Z, and then we say it's A, and then B, and then C. Okay, do this. So it takes the value of vector. Okay. Let me check. It's like doing something wrong because it should be like going together, but there's something missing. Let me try print and then paste I and j. Okay, so now it's printing a string. Okay, now it's working. So for the first one, I is taking the value 1, and then J is taking the string, the character A, and then you combine it with paste function. Like first I is 1, and then J is A, and then you print this, and that's 1A. And then automatically you must go through everything in J first before I can move to 2. So you can see like IA, IB, IC, and then I is changed to 2, and then 2A, 2B, 2C, and then I is changed to 3, and then 3A, 3B, 3D. Yeah. That's it for loop. And we can go on to while loop. So while loop has a basic syntax similar to a for loop, but there's something a bit different. For example, we have first defined x as a 4, and then we say while x is less than 7, we run the following things. We can just print x is still less than 7, and then we must do something to make x increase so that it's not less than 7. So we can do x plus 1, and we can run this. So x is 4, and then we can run this. So it prints x is still less than 7 3 times. Why it's printing 3 times? Because in the beginning x is 4, so while loop values like 4 is less than 7, and then it prints this message, the first message. Then x is 4 plus 1, so x is 5 now. So x is 5, it goes to the beginning, and then 5 is less than 7, so it's printing this message. And then 5 plus 1, now x is 6. 6 is less than 7, so it's printing this message again. And then we do it one more time, 6 plus 1, so x is 7. So 7 is not less than 7 because 7 is equal to 7. If we do like less than or equal to 7, something like this, then it will print this message 4 times. Okay, so we need to run this again, and then run this again. So it's 4 times, printing this message 4 times, because the last one is saying that x is 7, 7 is equal to 7. So this condition is true. 7 is equal to 7 is true. So it's printing one more message. Yeah. That's how if, else, and for and while loop works. Yeah. Okay. So we will talk about vector next. So vector. So we've already talked about vector so many times, but this time we're just dive a bit deeper into what vector is. So we can always create a vector, for example, x, by using this kind of function, C function. And we can say 1, 2, 3, and 6, and 9, something like this. Then x is a vector. Or we can do something like this, bracketed. So it's both assigning to x and also executing the value of x. So R is vectorized. So this means that if you have a vector that contains like these elements, and then you can just do this x times like 2, like 2. And it will automatically like for each of the elements in x, it will automatically apply like times 2 to each element of x. So that means that makes things a lot easier in writing codes in R, or else like this. So for I in x, for I in every element in x, and then you have to write a lot of codes like doing something like this. For I in x, for I in the length of x, for I in 1 to the length of x. So when you do this length of x, it just say, oh, x has 5 elements. And then I is running, you have to do this and you write xi for each element in x. So, and then you times it by 2, and then you run it. Okay. Mm. Mm.
Oh, Cici, you are you trying to see if x is multiplied by 2?
Yeah, I'm trying to see the results of
Yeah.
this.
But you just did the multiplication inside the for loop, but you didn't like save the value as anything. Like you didn't save the value back into x at that position.
Oh, okay, okay,
That's
I
why
see.
it's not showing up in the
Okay,
vector as you expected. Yeah.
okay, I see. And then you run it, and it works like this. Yeah. So basically, if like since R is vectorized, you can just do something like this, a simple code like this, and then you can get the result. But if R is not vectorized, you have to write a lot of codes, and then you get the result. Yeah, and something like this. So that means R is vectorized, and then so since R is vectorized, we don't need to write that much code. And then we can try one more thing. For example, if we just say y is like from 6 to 9, and then we say we want to do vector addition, we can just do this x plus y. Okay, so I haven't defined. Okay. And it gives a warning because y is having the length 4, and x is having the length 5. but it still like allows us to do the addition. In this case, it's because I'll do x and then y. So x, okay, x is this and y is this. And then, okay. So basically it's adding like 6 plus 1, 7 plus 2. So 6 plus 1 is 7, and 6 plus, no, 1 plus 6 is 7, 2 plus 8 is, 2 plus 7 is 9, and 3 plus 8 is 11. And then for the last one, is basically, uh, Jasmine, sorry to bother you again. Uh, how come this is
Fine. Are you trying to? Sorry, I was trying to help somebody join.
okay?
So can you just go
Um,
back? What were you trying to do here again?
I'm just adding x and y. X is this, and then y is this.
Oh,
I see. Sorry, sorry, guys. So it's basically, so because y is only like 4 values, and then for each of those 4 values, like 6, 7, 8, and 9, and then it's, so that's why you're saying seeing 15 and 15. Okay, there's nothing wrong with it. Mm, yeah. Mm. So I think we are all good to do our challenge, the first challenge. Uh, I'll copy it down and paste it to post it. Okay. So this is a challenge. You guys can try this. And once you're done, you can just write in the Clever notebook your name. So this is basically saying that you have to manipulate the pop function in gapminder data set, and then you change it so that the unit is in millions of people. So right now population is just is a large number, and you have to make it so that the unit is in million.
yeah, and previously we've used the Gapminder data set, so if you haven't loaded it already, you just need to call library Gapminder beforehand so that you can get that data set. You can complete the challenge.
Mhm. And once you're done, you can click the green check mark.
Maybe everybody's a bit shy today, Cici, so maybe give it a little
Okay,
more time, a minute, and then we can go over the answer maybe.
sure. So it's 45. So we can let's try this together. So we can load the Gapminder dataset. So it's a, and then we can create a new variable called a pop in million of people. So like this, the new variable is pop mil. And then we can assign it to a Gapminder and then slash the pop variable that it already contains, pop variable, and then so we can do mass operation like divided by 1 million, six zeros, and then let's run this. So now the Gapminder dataset is has this new variable pop mil, and then now it's in the unit million. As you can see, all these are decimals right now. Yeah. Yeah, that's it for this challenge. Let's try another challenge. Challenge 2. So on a simple graph, and then we can plot something. So on a graph, and then plot the population in millions. That means a new variable, and then again year, and you can just put year in the x-axis, and then population in million, and then that's the first part of this challenge. If you know how to do this part, you can also like challenge yourself a bit more by doing the second part of this challenge, like graph only for these 3 countries, China, India, and Indonesia. Same plot, like the y-axis is population in million, and then the x-axis is year. And once you are done, you can write in the collaborative notebook. Yeah. Your name. We'll wait until 6:52 or 55, and then we'll do it together.
Yeah, and Cici, after this challenge might be a good point to give everybody a 5-minute break before we
Yes.
function.
Okay. So let's do this together. Basically for the first part, it's not that hard for you guys, I think. So we just need ggplot, and then we say the data is a gapminder, and then we say the aesthetic, like x is equal to year variable, and then y is equal to the new variable that we just created, the population in million, and then we can just graph it. ggplot, geom point. Geom point, okay. Did I, so I, library, ggplot2, then geom, okay, I spelled it wrong. Okay, this will be the graph. Okay, and then we can try the second one. We can subset these years out of the gapminder data set. So there's basically three methods or more methods, but I'm going to just introduce to you guys these three methods. So it's so let's create so gapminder, then filter, use the filter function, and we can filter out all the country that equals to a China, or country is equal to India, or the country is equal to Indonesia. And then this is a subset, and we can give it to a data frame, a new data frame, a temporary data frame, and then we plot based on this data frame. The f is data equals to df, and then aesthetic is x equals to year, and y equals to pop mill, and then add g point. Okay, so this is our graph. Then we want the legend, because we can't figure out which of these dots is for which country. So we can just say color equals to country. That gives us a bit more color. That's one of the options of how to do this. And then the second option of trying to like filter out these three countries is by doing this. So df2, we can just say gapminder, and then we can filter country, and then in a vector of the country names, for example, China, and then India, and then Indonesia. That way is a better way because it's writing less code than this line. This one is a better code. So we can just do the same thing. Basically how to graph it is the same. So df2, yeah. And then the third way is it's just that we can just do this kind of thing. So ggplot and then data equals to gap minder, and then we can just subset the country gap minder, the gap minder is a bit of country, and then we say it's like in, and then the country set. So basically it's just this piece, and then come on. And then we can just say aesthetic AES, just this piece, and then plus G on point. Okay, it's the same thing, and you can just make this piece of the third method a bit better. You can just do this. So you just change this whole piece of this vector, you just give it a name, for example, country vector. So we can just create a new country vector, and then we assign it to this value. So it's a bit more readable than the previous one. And this one is the same thing. We can always improve our graph, like this graph. We can add some labels. We can just add, for example, x equals to like the capital letter Y, the year, and then Y is equal to population, and then in millions. And then the title, we can give it a title. Okay. Population growth. Population growth in over time. And we can also change the legend, this, and give it a capital letter. So we do it by saying color equals to the country, because we use the color here for assigning the countries. And then we can run this code. lab, label, sorry. Labs, okay. Now it looks much better. Mhm. And now it's time to take a break. If you have questions, you can feel free to open your mic.
So,
Thank you.
Cici, do we want to take like a 5-minute break and have one back by 7:10?
Yeah, let's come back at 7:10 or 7:15.
7, yeah, let's just do 7:10.
Okay. So it's 7:10. We can get started on the next part. So before I move on, because we are printing graph, and if you guys want to know how to save your graph, so you can basically do something like this. So GG save, and then give the location where you want to save your graph. So the path equals to, for example, let me see my current working directory by just typing get wt. It's working. Okay, so this is my working directory. I can just type it here. And then I say save my output graph in this name. So I call it like output graph 1, and then .pdf. I can save it in the file format, PDF. So I can just do this, and it says it's saving as a image. So it's basically saving as a graph in my, so here is the output. Oh, it's not this one, it's output graph. So that's a graph I'll be saving. So as long as you type this piece of code right below the graph you want to save, for example, this one, then it saves as this, but exactly the same thing as what you are printing. So that's one quick tip, that if you are writing your paper and you want all your picture format to be the same, you can just create something like this. So let's call it old theme, and then you can just create a theme of yourself, of your own, and then write using this function, and you change the theme. So let's say plot background equals to element rec. So we fill it with a color, any color you want, any color that's accepted by R, for example, Alice blue. And then so with this, you can basically change your graph. So the background now is in this Alice blue color. You can also change the color of this one. So you just need to add inside. So oh, okay. Okay, so add outside. So panel background. The element rectangle equals to any color you like. So corn, silk, and then color equals to A. Then you can try this and then plot your graph again. Now you can see it's changing to a bit of yellow color, and this is a bit of blue color. You can also like make the title like bold. You can just do something like this. So plot dot title equals to element text, and then you say face equals to, you tell it to make it bold, and then you can also change the size of the title. You say size equals to 12, and then you try to draw the graph again after you run the code. You just, now it's bold, and then you can see, yeah, the graph will, you're like just changing your own thing. And then as long as you just run this code, and then for all the graphs you plot after this or before this, as long as you just run this, all the graph will be in like this kind of theme. So the title will be bold, then the background will be in this kind of color. Yeah, let's move on to talking about functions. Yeah.
Leave the plot. I just wanted to point out for GG save that you used earlier. You can also look into help documentation kind of for more info on that, but GG save just defaults for the plot that it saves to the last plot displayed, which is handy, but also sometimes can be a bit confusing if you're like trying out a bunch of things and you rerun your code and you realize that's not saving the correct plot. Sometimes it might be easier to specify which, like save your plot as a variable and then specify which plots you're saving to make sure you're saving the correct one. So I just thought I'd point that out, but continue.
Yeah. Okay, so we will talk about functions. Okay, so functions. So the basic syntax of a function is that when you create your own function, for example, when we convert Fahrenheit to Kelvin, we can create our own function. We can just say create a name of our function to Kelvin, and then we want our own function, so we just run this function, and then we create a private variable, like temporary variable, and then we do the function inside of this. So this temp basically is the input we want to receive. We're receiving from the global environment when the user is calling to this function, and then it gives us the value as input. Then we use this input to do everything in our function. So let's create create a Kelvin variable, and then we want to change this Fahrenheit input to Kelvin. So we just need to do the mathematics. So temp, we just minus 32, and then we times 5 divided by 9, and then we add the 22, okay, yeah, that's basically the function of changing the Fahrenheit unit to a Kelvin unit. And then after we get this number, we need to return it. We need to bracket the value, the variable we want to return. We want to return Kelvin, and we return it. Okay, so let's try this function if it works. Okay, it's working. So how do we call it in the global environment is by calling the name of the function, this name, and then we give it input. For example, we say 32, and we see, okay, 32 is the Fahrenheit in Fahrenheit unit, and then this is in the Kelvin unit. This is basically the freezing point of water. That's a successful function, and it's been created. We can also give the we can also give this function a vector input. It also works. For example, if we create input variable, for example, c equals to 32 to 35, and then we call this function again, and then we say input. Okay, so input, and then it gives us a vector output. This one was 32, and then it's correct. This one is the 33 Fahrenheit converted to 233 Kelvin, and that's it. So here is the challenge. Okay, so let's talk about the condition for like getting the right input. We need to check the condition to make sure the input we receive is correct, is what we want to receive. Here we want to receive a number. We don't want to receive a character or a string or any other like things. So how do we do that? Is that we just need to add a piece of condition at the beginning of our function. So we say this one is a new function, so with condition, okay, so we can just we can use if function, if, and then use this function, is dot numeric, and then check if the input is a numeric value. If it is a numeric value, then is numeric function will return true. If it's not, if it's returning false, then we want it to return something that says the input is wrong. So as long as this one is false, that means we want the condition to be not false. That's true. So as long as not false is true, this condition is true, if we'll do something like this. to stop the function to keep on running, and then ask the user to input a valid input. So stop, this function stops the whole function. So give it a message, an output message to the user. So it says the input is invalid. Input must be numeric, something like this. So let's run this, and then let's try this function. The name of function is a bit long, but you can always change it to something shorter. Yeah, it's printing the message that we wanted to print. So I'm giving it invalid input, the string, and then it detects that the input is invalid because it's not numeric. And then it stops the whole function to continue running by printing this message. Here is a message. And this way we make sure our function always receives a valid input. So now this is it says there's an error, so we need to change it to, for example, 32. Yeah, it's working with the correct input now. Okay, so this is one way to check the condition of the input if the input is valid by using if and then the stop function. And then another method for checking the condition is to use a function called if stop if not function. So stop if not function, this function. So this function works the same as this whole piece of code. So we just need stop if not, and then we say is dot numeric, and then the input. So as long as this one is false, stop if not will start working. And then let's see how it works. So let's call this function 2 with condition 2. Okay. Let's try this function. And we tried this by giving it an invalid input and see if it works. Okay, so there's an error because the input is invalid. Okay, we need to first run this.
Curly brackets instead of the round brackets.
Oh yeah, that's right. Thank you. Okay, so unexpected input. That means stop if not is working because it detects the input is invalid. It's not numeric, so it says something's wrong, unexpected input. So we need to change the input. And then we change it to 32. Okay. Okay, I see. I'm using, because I'm using two kinds of keyboards. One is like typing Chinese, one is typing English. Sometimes when I just type the Chinese bracket, it doesn't, the R program doesn't read that, so it's printing a message. Now it's working. Okay, it's working. Okay, so here's a challenge, and we try to create. Okay. So the new challenge is for you to create a new function that converts Kelvin to Celsius. And then basically the function is that you just need to subtract this number from Kelvin, then you get Celsius. You guys can try it, and we will continue at 7:32. Yeah. Now it's 7:32. Let's continue. So we need to create this function. We can just do function and then create any kind of temporary variable, for example, AAA. And then we say that's the input value. And we just give it a name, AAA. It can be any name, valid name. So we create a Celsius, Celsius variable, and then our input should be a Kelvin, and then as long as we minus 27315, and then we can get the Celsius, and then we return Celsius. And that's a simple function, so we can try. For example, we can say Kelvin to Celsius. We just need to, for example, say 300 Kelvin. Okay, we have it run. Oh, temp not found. Okay, I see. Okay. Okay. Now 300 Kelvin is converted to 26 Celsius, and that works. We can always add the condition So stop if not, stop if not. And then we say is dot numeric function to check if our input is valid. And then as long as it's not valid, stop if not will work. This one works because it's valid. We try invalid input. For example, this one, it says it's arrow is not true. So there's an arrow we need to change to a valid number. And that's this condition works. It checks our valid input. So the next one is to use a function inside another function. I believe you guys already know how to do it. It's basically, we can just try doing it together. So we can convert Fahrenheit to Celsius. So we can do Fahrenheit to Celsius. Celsius. Okay, so Celsius. And we can create this new function and with temper variable, call it any name if you want. And then we can, we first give this function a number. So we can check if it's valid, stop if not, is not numeric, and then temp. And this one checks the valid input, and then we can start writing our content of the function. So we receive a Fahrenheit and we want to change it to Celsius, and we already write two functions. One is to change Fahrenheit to Kelvin, and the other one is to change Kelvin to Celsius. So we can utilize these two functions. For example, this one, we can just use this function and give it temp. So we create Kelvin K, okay, with this function. And then we want to change Kelvin to Celsius. So we use the other function, which is this function, Kelvin to Celsius. We can just say, put the K here. So now it's changing to Celsius. And then we return this last output, Celsius. And then this is a valid function. We can try. So we can just say Fahrenheit to Celsius, and we say 32. And it's because 32 is like freezing point to Celsius, it's basically 0. That's correct. And then, so you can write as much function as you want. And then basically, if you write a lot of functions for yourself and you want to use it for all the script, like whenever you open a new script and you want to you don't want to write your like function again and again, like in different folder, then you can just save it. So we can create a script where we can save all of our functions inside the script. So okay, so this, we just wrote three functions, and we can just store it in this R script. And store it in the script and then save it. Save it in a name, for example, R function, R functions, and save it. And then inside here, you can just see you saved the R function in the script, and whenever you open a new markdown or a new R script and you want to start writing new piece of code, but you want to refer to the function in this file, you can just say source and then the location where your script of functions is stored. So get wd, so that's where I save my function script. And then you just give it a script and you call onto this folder, this script name. So it's R functions.r. And then it's working. So assuming I don't have all these code, and then I want to use the Fahrenheit to Kelvin function in this script, I can just say source and then call to the function 32, and it's working. Just remember, you need to call before you can. You need to write this piece of code before you can call to your function in the script. Yeah, that's basically everything about function. And then next we will talk about like global variable and the private variable, global environment and private environment. So everything inside a function will be the private environment. Everything outside the function, for example, this code, is in the global environment. And if you create a function and then so for example, a function called f, and you say function, and then you temp, and then you want to create a every variable you create inside this function, for example, fff, and then you store it as temp times 2. This fff will not be will be only a private variable. It's not a global variable, but because if you create this and then you want to call fff, like okay, so
It's because you're outside of a code chunk right now.
Oh yeah, I see. Okay. Okay, so this is a function, and then you want to call to fff. Oh. Okay. There's arrow because fff is not found. It's only a private variable. And if you want to create a global variable that you can access outside in the global environment, you can just do something like this, like double this, and then it creates a variable called FFF. Okay, never mind, just ignore this part. Am I doing something wrong? Okay.
You were trying to assign FFF to the global.
Yeah, I was reading the script and then they say if I use this assignment operator, then this one will be a global variable.
That should work. Is it? Did you run the function?
Let me try. Okay, I think I need to run the function maybe. For example, 3, and then we see, okay, it's probably working. Because we didn't return FFF in our function, but we can get the value of FFF. Never mind.
Yeah, I think you got the value of FFF. You can also see it in the top right near
Yeah.
there.
Okay. I
Like,
see.
you can do that. I would caution doing that. It's good to know that that's an option, but sometimes you end up mixing kind of environments. So it starts to get confusing where you're defining the variables. But yeah, there are some cases where this you might need to reach and do this in your day to day, but yeah, before you do that, kind of consider what you're actually trying to accomplish with the function before doing that. It's much safer to just return whatever you're trying to do in the function at the very end.
Yeah, it's not very good to use this, but it's good to know that it exists. So we can continue with like a logical comparison with vectors. So we know that if we assign a vector to x, and then we want to compare if x is greater than 2, we can do it. And then R will do on each element, do logical comparison on each element of x and say 1 is greater than 2 is false, 2 is greater than 2, no, it's not true, it's false, and then 3 is greater than 2, true, true. And then you can do something like this. You can also do something like not greater than 2. Okay. So I think it only works with not equal to 2. Okay. So 1 is not equal to 2, 2 is equal to 2, so it's false because we want 2 is not equal to 2 to be true, but it's false. And the other ones are true. And we can also use the function any. We can try any x is greater than 2. Is there any like element in x that is greater than 2? It's asking this question. Is there any element in x that's greater than 2? True, because 3 or 4 is greater than 2. And as long as there exists one truth value, then any will say it's true. And all function is saying that only when all the elements are greater than 2, then all will return true. But as long as there's one false value, then it will return false. That's two functions you can use.
Well, Cici, do you want to maybe provide some examples where might like using any and all might be helpful, maybe in kind of what we learned earlier today with like the if statements and whatnot?
Yeah, definitely. So, okay, so let's do something like this. So let's try to filter out the Gapminder dataset with using this function. So Gapminder, and then we can do this. So, actually we can use if function. So if Gapminder, we want to subset the year, all the rows that has year equal to 2002. Try to do something like this, and we can use any if there exists a row in the Gapminder data set with year equal to 2002, then any will return will return true. And then if we can print something like this. We detected a observation or row in the Gapminder data set that is recorded for the year 2002. We can try doing this. Let's see if the Gapminder dataset has a row that is recorded with year 2002. Let's try this. Oh, we actually detected an observation where a row that has the year 2002. So this tells us something, that if we want to analyze the data set in 2002, then this tells us there exists this data set, so we can analyze. So we can then say Gapminder. We can plot a graph in 2002. For example, GG plot Gapminder, and then Gapminder year equals to 2002, and then AES, and then X is GDP. Let me see. So what's the variable called? Okay, so for example, GDP per cap, and then we can say Y is equal to life expectancy, and then we can plot this. geom point. Yeah, and we can plot this. And remember that previously we set the theme to give it a bit a yellowish color. So now the theme still applies, and we can plot this graph. And all these data sets are from 2002. So in this case, we know there exists this data, so we can write codes about it. So it's useful to write something like this. Yeah, and if you write all, basically, if you subset a new data frame, and then you give it like Gapminder, you tell it like to write all the data sets into DF, and then you can also check if all DF equal DF slash year equal 2002, and print if true, print all is this, and try. Yeah, so because we subset, it's just a verification, verify that all of our data in DF is has the year in 2002, and that's correct. It's saying it's correct. Yeah, that's it.
I think this might seem a bit trivial, like just for like we're only working with one data set right now, one Gapminder data set, but maybe in your work you might have data tables for kind of many years spread over multiple data frames, and you don't necessarily want to be hand checking each one of them. So this is kind of where this comes in handy that Cici just showed you, that you can use a combination of like the if else statements and kind of tell your R script to do certain things if it meets a certain condition. So yeah, building upon this can be really powerful. And if you kind of want to go further with what Cici just showed you here and kind of make this a function so that you can change the year easily, that will also kind of take your programming to like a new level where no matter kind of what question, maybe your boss is like, oh, I don't want to see data from 2002 anymore, I want to see data from 2010, you can easily update your code and just give them the results. So,
yeah. Yeah. Yeah, that's all the material for today. Today we just talked about the if and else function, and then the for loop, while loop, and we talked about vector, and we also talked about how to write our own function and store it in a file that we can refer to in any other script we will write in the future. And that's it for today. And if you guys have the time, please like just write in the sticky notes and give us some feedback about this lecture.